Hello, Shubham. Please start.
Okay, so good evening, everyone. I welcome you all for today's webinar. And the today's webinar topic is basically on battery pack design using SolidWorks. So just wait a second, allow me to share my screen. So uh, today's webinar topic, which is like design a battery pack using SolidWorks. So before dive into the SolidWorks software, that how I have like made a battery pack. Which in this slide I would like to tell you that what are the basic components which are used while constructing a battery pack. So let's dive into this. So uh, so as we all know that battery pack are the crucial component which are designed to store like substantial energy and provide high power output for some specific applications, like in electric vehicles we are using it. So this nowadays as we know that we are utilizing a lithium ion technology uh, because it is preferred as a superior energy and power, and also have a high power density compared to the alternates or different batteries like lead acid batteries or nickel metal hydride batteries.
Mhm.
So each individual batteries like cells operates within a specific voltage range, which is basically dictated by its chemistry, and has a limitation on the amount of current it can deliver or receive. So to meet the voltage requirement of EVs, battery pack system connects multiple cells in series. So this series connection adapts the voltage of each cell to achieve the total voltage needed to power the vehicle effectively. So the design approach not only leverages the high energy density of lithium ion cells, but also it ensures that the pack can deliver sufficient power like for accelerating the vehicle and maintains its operational performance. So if we go for the overall battery pack plays a critical role in the functionality and efficiency of electric vehicle, to which balance energy storage capacity and also used for power delivery capability to meet the demand of modern transportation needs. So here, if we connect with we talk in context with the electric vehicle. So like there are two types: high voltage and low voltage. So in high voltage, basically typically refers to like direct current voltage, which is above 60 degree. So as per international standard ISO like 64693, like they have categorized voltage into two class A and class B. So for DC supply, if the voltage is between the range 0 to 60, it is considered as a low voltage, and above 60 to 60 degree 60 volt, it is considered as like high voltage. Similarly, if we'll go for the AC supply, 0 to 30 range, it is considered as low, and above 30, it is considered as high voltage. So basically, what this high voltage basically creates a threshold, a limit, which is basically important to minimize the current needed for a given power level. And this reduction in current, basically what it do, it reduces the power losses due to the electrical resistance, and this is important for the efficient energy transmission throughout the vehicle. And also by using this high voltage supply, the required thickness of a conductor, like what we are using a cable or a bar, it is also reduced. So thinner conductor are lighter and cheaper, which are beneficial for overall weight and cost of the vehicle. Also, lower electrical resistance in the system is achieved through the higher voltage, which leads to the better overall efficiency. So this means that more battery's energy is used for the proportion rather than being lost as heat. So in a EVs, various key components such as inverter, electric motors, and chargers are designed to operate around the nominal voltage of this battery pack. So the nominal voltage of any battery pack or a cell is very much critical factor for influencing the performance and design of the components. So now, what is the component of the battery pack? What basically what we are using in a battery pack? So while designing any of the battery pack, so for different electric vehicles, like the requirement varies according to the applications. If you go for hybrid electric vehicle, which is a combination of conventional internal combustion engine and electric motor. So the battery pack here basically are designed for the moderate energy content, but also we have to keep in mind that we need a high power density in this battery pack design during for hybrid electric vehicle. You will go for the battery electric vehicle, like pure battery electric vehicle. So in this, we require a battery pack with high energy density to maximize the driving range. And we can while power density is also important, but the primary focus for BEV is storing as much as more energy to extend the distance of the vehicle over a single charge. And if you go for the fuel cell electric vehicle, so in that we are using a hydrogen cell to generate electricity, so which complement the battery pack. So in fuel cell, basically what we do, we prioritize the low energy content, but we need a high power density. So while selection of cells for to make a battery pack, we need to see the chemistry and what exact requirement for different application. We have to consider that in mind as well. So battery pack component, sorry, if we go for apart from vehicle type, uh, battery pack also consists of several components. We have a battery module. This battery module is basically it is grouped as the lithium ion cell, which are connected in series or parallel. And if we connect these lithium ion series, definitely the overall voltage will increase, and which is essential for the powering the vehicle electric motors. Even and also to like BMS is also used here to monitor and manage the battery pack here. So in this image, what is shown here is we have used here battery for a battery pack. So battery pack basically we consider the central component that encompasses all the other parts. So it is the main energy storage for the electric vehicle. So the first and critical component is BMS, which monitor and manage the battery pack of the operations in the electric vehicle, and it also ensure that battery operates safely and efficiently by controlling the charging and discharging process, cell balancing and temperature management as well. So uh, what exactly in battery pack, we have a battery module. So these battery module individually represent the battery pack. Battery pack is a combined it to under battery pack we have a battery module that makes a battery pack. Like number of cells combines makes a battery pack. So each module contains a, like you can say, a lithium ion cell, which are connected in series and parallel to achieve this desired voltage and current capacity for that. Also we are using a cooling system which are responsible for like maintaining cells at the optimum temperature, which prevents the overheating and also the degradation of battery performance over lifespan. Also we're using a housing and interface. These housing basically protects the battery pack from the external impact, and the environmental condition. It also provide the necessary interface for connecting the batteries to the vehicle electrical system as well. Even one of the component of battery pack is the switch box. So this component contain like the voltage switches, high voltage switches, which is directly coming from the battery pack, and fuse is also installed there. So what does during like emergency or is there any short circuit or any problem, these fuse are used to disconnect the power supply to like for the to maintain for the maintenance purpose or to maintain the vehicle safety. So now okay. Now, say like safety measures in the view in the battery pack is also there, like monitoring cell voltage, pack current, as well as the temperature. So each cell in like within a battery pack is closely monitored and for the voltage, and ensures that the each cells remain with the safe voltage range, which prevents like deep discharging, which can damage the cell or overcharge, which can lead to the thermal runaway, and the also can reaches to the fire as well. Also, during safety point of view, we should monitor the current flow in or out of the battery pack, which help to detect the abnormal conditions such as short circuit or excess current drawn, which could indicate the fault. Even temperature sensors also there, which is connected to the battery pack, uh, uh, like control system, which thoroughly just take the readings and the temperature of the cells, and indicates that whether the cell is in overheating condition or underheating, or it is in the optimum range. Even switch box, we are using a switch box. This device basically continue check the electrical isolation between the high voltage component and the vehicle chassis, like ensure that no unintended like current path could pose a short hazard like that. So these even it do have a current sensor. Then these sensors basically monitor the current at various points within the battery pack to detect any anomalies or help to manage the safe operation of the battery within the battery pack. Even switch boxes within the battery pack house mechanism to quickly disconnect the battery in case of any detected fault, or preventing further damage and enhancing the safety for. Also, in battery pack, effective cooling technique is also used. Like keeping the battery cell at the optimum temperature is also a critical uh, steps for maintaining their performance, efficiency, and also the longevity. So, effective cooling systems like liquid cooling, air cooling, PCM cooling is used to dissipate heat generated during the operation. So, especially at the high load condition, like when vehicle is at rapid acceleration, or we are using any fast charging mode to charge the battery pack. So also the housing what we are using, because in battery pack we have to use the housing as well. So housing should be robust and it should be durable to protect at- any of the harness, any of the external forces acting on the battery pack. So the component of the battery pack basically whole the component of the battery pack is basically enclosed in the housing, which should be robust to endure that the entire lifetime of the cycle, to increase the life cycle of the vehicle as well as the battery pack. So these housing basically is used to like we are using it to protect the internal component, like from if we have any harsh environment or operating conditions, like extreme temperature or moisture, vibration or physical, if some impact is acting on that. So housing is also plays one of the main role in a battery pack design. And also like the housing integrates interface, like for high voltage plugs in a housing of the battery pack. We have a slot for high voltage plug, which are basically essential for safely connecting the battery pack to the vehicle powertrain and also with the charging infrastructure. So even in a housing we have a interface, a communication link interface as well, which ensures the seamless communication between the battery management and the vehicle control system, and also effectively communicate in the vital like for monitoring and managing the battery pack performance and safety. So these are the some components of this. So in battery pack, so number of battery modules are used, which combined makes a battery pack. So battery pack, if we see, uh, so modular battery pack, what we are using designs, which basically designs assembling battery modules with the numbers of like lithium ion cell. So and this approach simplifies the production and transportation, and also for the maintenance. So each module basically, if we go into the each module section, so each module operates at a very relatively low voltage, and typically 60 voltage. Why? Because to enhance the safety and easily handling during the production and transportation. And also in battery module, like cells are encapsulated within a robust module housing. So these housing provide a mechanical stability and protecting the cell from the physical damage and also from the environmental effects. So the module basically, like the module what we are using, battery module, so housing is not only to provide the mechanical stability but also ensure that the cell are securely held in the place and reduce the risk management or like movement and damage due to the vibration or impact on the effect on the battery pack, to reduce that. So here an illustration of schematic of a battery module and its component. So here we we have like cells are arranged in series and parallel combinations, and each cells are being monitored with the help of cell supervision unit. So CSC, we used to say CSC. So cell supervision units are used to monitor this. And also, like cell this cell supervision circuit is connected with cell interconnection system. What is cell interconnection system? In cell interconnection system, basically what the connections of all the cells are done, from each cells which is connected in parallel, or sorry, in series, or also we have to take a individual cell voltage level, that whether it is at the optimum voltage. So we are using a cell interconnection system, and this cell interconnection system is connected to the cell supervision circuit, which takes the data, and this cell supervision circuit send the data to the battery management system. So this is how it works. Now battery modules, about like more about like cell modules, like in battery modules, modules in a battery system basically also plays a essential for managing the individual cells which makes up a battery pack. So if we say these modules serves two primary principle, like interconnecting cells and supervision their operations. So firstly, as I told before, the cell interconnection systems physically they connect all the cell together. So these systems like basically enables cells to enables to arrange both in series and parallel configuration, which determine that the voltage and the capacity of overall battery pack. And a cell in the series, as we know, it increase the voltage, while cell in parallel increase the capacity. So the interconnection system also used to ensure the reliable electrical connections between these cells, which are crucial for efficient power transfer. Secondly, each like you will say each module is being supervision with the help of cell supervision circuit, as I told before about CSC. So these circuit are basically responsible for monitoring the two key parameters like cell voltage and temperature. So monitoring cell voltage is crucial because it ensure that no individual cell that get overcharged or discharge beyond the safe limit. which can damage the like optimum operating condition. Even overheating can also degrade the performance and the lifespan. So the CSC is also one of the important component of a battery pack, which continuously monitor the parameters to provide the real time data like to the BMS. And basically we need to facilitate this monitoring like function, wire harness is also used. So these are the sequence that what we are used to the connection. So these wire harness basically connect to the CSC, to the cell interconnection system, which allow to access each individual cell's voltage and temperature. And this data which is fed by these components is then sent back to the BMS, send this to the BMS, which basically make a decision regarding the charging, discharging, or overall health management. So these are the key components which are basically used in a like battery pack, complete battery pack design. And so the core element within a like cell element is a battery cell themselves. Like these cells can like vary from like we have cells geometry, various cell geometries like prismatic, cylindrical, pouch. So the choice of this cell type depends on like the cost, longevity, energy density, that how much amount of energy it can store per unit volume or weight, even the power rate density, that the rate at which the energy can be drawn from the cell. So this factor depends the choice of the cells what we are choosing. Even the module itself provides a protective and structural casing that holds the securely in the place. And this housing is basically designed to accommodate like different cell types and size, which ensures they fit slungy and are like well protected. Now even like if we see if we go like upon like selection criteria, like at what factor we can select the cell type. So first we have to consider the cost, like the cost effectiveness of the cell type is the first of the crucial factor, like particularly for the large scale application where overall pack cost impact market cost. So this is the first factor we should consider. Second is the longevity, like long term durability and cycle life are essential, especially like in case of we are using in case of in our electric vehicles where battery replacement is costly. So longevity and durability is one of the key factor. Even higher energy density allows more energy storage in the small volume or weight, so which is advantageous for us for like portable electronic for the portable electronics and electrical vehicle to maximize the range of the vehicle. Even higher power density, which basically it supports the rapid charging and discharging, which are critical for the applications like requiring higher burst of power in electric vehicles. So these are the some selection criteria of the cells, how which type of cell we have to choose uh, according to this criteria. Even module also, when while designing a module must also adhere to the like some standard which is set whether it's an international standard or a national standard. The module should adhere that safety, reliability, and interoperability. So these standard like compasses like it should be mechanical robust, it should have mechanical robustness, like ability to withstand the shocks and the vibration. Even it should also have should have like environmental durable, it should be environmental like durable, which like resistance to the moisture, temperature at also work at extreme temperature. And it should also have a good electrical performance, should efficient energy transfer and monitoring. After doing this, last is the testing and validation. Like before giving deployed to the market, modules should undergo rigorous testing to like validate the performance under the real world condition. And these includes like simulating test shocks, vibrations, And
extreme stress. Hello,
also environmental stresses encountered.
hello, hello.
Yeah, hello.
What is it? What is the topic given and what is it you're talking?
Yeah, this is the basic what exactly
We
is
don't
now.
need basics. Okay, you stick to your topic.
Okay,
Don't waste our
just
time.
I'm just diving into that only.
No, there is too much.
Okay,
First, stick to your topic.
okay. One second, just. So this this is in SolidWorks. Like we are using this how to make a battery pack using a SolidWorks. So first, what we'll do, we'll make an individual component, like what basically use in the battery pack, like cells, battery holder, and wire harness, and BMS, and these all are the connections, and also we are cell connectors, like nickel strip, metallic strip, we are using it to connect it. So first, we'll do, we'll individually in SolidWorks we'll make a individual parts, and then we'll assemble it to form a battery pack. So this if I'll go for full design part, if I'll make every parts here, so it will take long time. So I have already made it. Now I explain what tools is being used and how we have made this battery pack. So if we see first cell, so one second. So in the cell we have a structure like this we have made with the, like, it's a 18650 cell we have taken, whose voltage is around 3.7 voltage and 2000 milliampere hour of the capacity of this each cell. So we have taken one cell now, and one cell, this is the geometry we have made with the radius 9, and height we have taken as a 60. So now we are using a revolve command. With the help of this revolve command, we'll make a cell. Right? This is the cell which, with the help of this revolve command, when we use this sketch and use the revolve command, this kind of cells are cell of this is a kind of cylindrical cell what we have made here. After that, now to make it little bit like what I have written here, like 18650 2000 3.7 volt hour. Now how I have written here, so to write this here, we have taken a plane over here, like this, like plane we have taken here, and this plane we have made a sketch, like we went directly to the sketch, and we have made a reference line. One second. So this is the reference line what we have made, and over this reference line, what the specification what you want to show to the like if you are making a project or to a customer, you can write the specification and chemistry of this cell, and after that you can just use a command known as wrap command, and with the help of that wrap command, it's getting so laggy now. So with the help of that wrap command, this text what you have written, it will be imprints on the surface of the cell what you have used. In on what surface you want, you can use, with the help of this wrap command, like I'm showing this. Yeah. So in this wrap command, you have to just select the surface over which you want this text to be written, and just after selecting that wrap command, at what thickness you know want to imprint, or you want to extrude, or you want to like cut it, you can use this. You use that thickness, and then you can just press OK, and you will get that the things what you have written is imprint on the cell. So this is a kind how we make a cell just for like make a battery pack. Now second, now definitely if we want to make a battery pack, we need a battery holder, because without holding a cell, it may like move from its position. So we have to hold that battery. So for that, we have made a battery pack holder. So to make a battery pack holder, first we have decided at what type of battery pack holder we have to use. So here I have used the interlocking battery pack holder, so that we can interlock it easily, and which is also easily available in market, because we have to choose accordingly. So I have used this battery pack with the cells is of 18. The dia of the cell is of around 18, so I have taken 19 as a width, uh, so that to understand, there should be a proper gapping between the battery pack mold. So after sketching this, I just, what we do, we extrude this up to certain height according to the design or need what you want. And after extruding it, definitely it is an interlocking, so you have to make you have to make a, like a body which is interlocked as an interference fit with the another holder, so you have to make that as well. After, so like this, first sketch what I have made as this. So this system I have made, in which this outer section which is coming out is been imprint, or it will interference fit with the another battery holder to make a stack of the battery. And two side we have done this, and another side if you'll see, here we have like use we have cut the material so that other battery holder can stuck here. So in this way, like we can make a battery holder in this. And to make surface finish, we have used certain fillet command to remove the sharpness of the edges. So this is how we make a battery holder, in which we basically hold the battery so that it cannot like change its shape. After making this, now we'll go for a assembly part. This is the part what we have made in a like SolidWorks part modeling. Now we have to assemble this part first. So how will you assemble? So like first what we'll do, we'll import, like from here insert component, we will import the component what we have saved what we have saved in the part modeling, like battery holder. We will import that component here, and after importing this, we'll import our cell as well. And see the cell, we have import the cell and we have import the holder. Now we have to apply some relation between the cell and the holder, and the relation between the cell and holder is basically given by the command. Here is the mate command. Either you have to coincide it, or you have to make parallel, perpendicular. It depends on the situation what you want. So if suppose this is a circular one, and also this cell is also circular, so we have to like coincide it. We what we'll do, either we can coincide the surface, or you can use the concentric command, so that the axis of both holder and the battery pack can align with each other. So this is how, while using this mate command, you can make this made this holder and your cell. After that, after holding cell, what I did, to save time or to save multiple relation, you can what do, you can make an array. How you can use, here we have an option called here, one second, yeah, here linear component. And so we can make a linear we can make a linear array or a pattern of the holder, or how much pack we want. Basically here I have used 8x8. It depends what type of voltage and capacity you need. So if suppose you want, here I have used 3.7 volt cell, and now have connected cell 8 cells in series. So 3.7 into 8, which will be the total voltage. In series connection, we'll get a total voltage overall. And if go for the parallel, the capacity will increase, voltage will be remaining same. So first we have to decide that how much voltage we need. Accordingly, we will take the cell as well as the holder what we need. After that, making this holder, the pattern we will make using this linear pattern. After that, same goes for the cell also. We can one second. Okay, we can import cells, one cell, or you can import, and then you can make an array. Now here you have seen that there is a negative port, since I have mentioned here, like there is a negative port, this is a positive port, and this is a negative port. So in series connection we have to make a combination of positive negative. Why? Because to increase the voltage. So in a adjacent, when we have kept in adjacent battery holder, so there will be an alternate of positive to negative, negative to positive connection. So so in SolidWorks what we can do, we can import only one cell with a holder, this, and another cell with a holder. Now you can use a this linear command, and with the help of this linear command you can like select this, and which phase you want. I want an array should be like it reverse or direct. You can change the direction from here, and at what distance you need. So for like I just want to suppose pattern this and at 19, and I need 9. So it will see, it will give an array. In assembly we can use an array. So while choosing this, distance should be correct, like center to center distance what you have taken. Since while I designed this battery holder, the end-to-end distance is 19 mm, and this cell's dia is 18 mm. So what while if you see here, these all cells are overlapped. Why? Because from center to center we there is a 19 distance considering the holder. So holder distance and the cell distance, overall it becomes a 19. So that's why it is overlap. So distance measurement should be very accurate, otherwise there will be if you are using like linear like pattern command or circular, any pattern, if distance measurement is not correct, then there will be a deviation in the path what you need. So this is how we have made the cell holder and then a cell pack, and this is how we make a alternate connection. Now if we see first line, this line, if we'll consider this line as front positive negative positive negative, so it is a series connection and it increases the voltage. Now if I want to increase the capacity, so if you see that positive positive connections are here, negative negative connection, negative positive positive negative negative, so it is a parallel connection. So parallel connection, what it do, it increase the capacity. So after making this, so now after that we need to connect these terminals internally. So we are using a cell connectors, so that we can achieve what we want, the voltage and the capacity what we want, we can achieve that. So we are using a interconnection connectors. So these are the cell connectors, like we have connected with positive negative one strip, and there is two options. Like again you can import this component from the from where you have saved, or you can also use an array command, so that or pattern command, so that you can reduce the time and as well. So I have also used here as a interconnection array command. So here it has been so we have to measure the distance, like at what distance it should be. So with the help of geometry, with the help of the distance measurement by calculating, we can measure the distance, and so and use the pattern command, we can connect this cells like this. So you see here the strip is connected between positive negative positive negative positive negative. In the similar way, it will go down. Here also cell is connected between positive negative positive negative positive negative, and once positive full terminal is left and another positive negative full terminal is left. So for this we will use an like this. So this is now we'll connect this positive terminal the positive and negative terminal which are connected parallel to each other are connected like this. Now when we do the wiring, so the from here from negative terminal one connection and from positive terminal one connection will take, I will take the output. But in real life we do not do this now. So what we use some as I told in the PPT, like cell supervision circuit and BMS we are using it. So there is a connections which we are using here. So we are using a wire harness concept here to like okay, so we are using a wire harness concept to do so. So if I show you the flow, that how will it the current flow will get, suppose this is a positive negative positive terminal, so positive to like here positive to negative and then negative positive to negative, then negative to positive, again this negative to positive. This is the loop which basically follows while we are making a battery pack, and finally we get the negative outside. So this loop, if it is not correctly made, definitely there will be a problem in voltage or capacity. So we should while making a battery pack, any battery pack using any 3D modeling software, we should see that whether this loop is being maintained, whether the like mating operations like this mates coincidence parallel, any like mate operations is used correctly or not. This is one of the main factor. Even according to your need, what voltage and capacity you need, you can make it, and according to that you can go for it. Now after that, we basically, now after making this the pack of the battery, what we do, we basically definitely we use a battery management system to manage this battery pack, like the cells, the volt cell voltage. So BMS, what it do, it monitors monitors that what will be the battery, is there any irregularities or over voltage or under voltage, so it cut the supply. So in the same way, like here, even battery in BMS there is a CSC inside BMS only. Here as a CSC we have used like cell supervision circuit. So this is a wire harness what. So this, if I zoom it, right, so it will see there is a, in BMS we have a positive and negative ports, and also a wire harness this port, where basically what happens, this small switch which is directly connected to the cell supervision circuit. So each we have basically in this, what we do each cells we are doing we basically we need to know the voltage of each cell, what is the voltage level of each cell during charging as well as discharging while charging. So from here we do connect to the each cell, like each cell where we have used in the this strip where we have used, we will be connecting this. So positive negative will get a voltage difference between that, and we come to know that what exactly the voltage actually a battery have. So this is how we'll connect the battery, like taking connections like this. And how we can make this connection, there are two options. First, SolidWorks electrical part is also there from where we can do it, but here also in this we can with the help of like 3D sketch, we can make a projector line through which from where we can like take the wires and connections, and after that we can use a sweep command, and we can convert this wire into a line into a wire. So if I'll go for like, it will show you once. So these are the pins which are connected, and these pins have a various pins, and these pins are in market are available for different BMS. Different pins are available because each BMS have its own capability to check the voltage difference between the cells, like how much it is capable to check the. So if here, as I have seen, as you have seen that here I have written 8s 30 volt 16 ampere. So 8s means 8 string means like 8 cells are kept in series, and these 8x series are connected to the parallel in the 8 direction. So these each cell module one, these 8 cells which are connected in series, or we can say it is the cell module, each layer of the cell module. And this is how, when we connect this each layer of cell module into a in parallel directions, then it increase the capacity, sorry. So after that, if you see here, like the positive terminal which is coming out from here, like from the BMS, the positive terminal, it is directly going out. This red color, this positive terminal from this pin is directly connected to the outside, and also and the negative terminal of this. So what happens, like from this negative terminal we have taken a connection to this B negative, and from B negative it is coming from the, like P internal, they might have a connections, like basically BMS is a part of electrical, so I can only help you out with how I have connected this. Inside electrical part is more there, that how they have connected this from B minus to P minus, like what are the rule of this. And okay, so these connections are done like this, and from basically, if the controller, this red and black, these two connection are sent to the controller. So in while designing this, we need a cell, a holder, and these cells should be like what we have made with the help of revolve command, and the dimension what which dimension we want to make, and the cell holder, like which are available in market, or if you have designed your according to your cell, if you are designed, you can use this softwares like part modeling software, and you can make it. After that, you have to assemble it directly. All the battery pack with all components we cannot make in a part model, so we have to split it. We have to first make a part using a tools which are used in the SolidWorks, and after making these tools, we will be assembling all this and make a battery pack. Now this is not complete yet. If we see that cells are arranged, we have made our parallel and series combination, we have used the wire harness, we have used the battery pack, but there is one more thing which we have to make, a cooling system. So what exactly, like when some at some point, like we need to do the analysis for our battery pack, what exactly we have made. So we need to have a cooling system, we need to have design a cooling system. So first we have to make a battery pack. After that, according to the battery pack and according to the dimension, we select which cooling system is best and what should be the dimension. So what like so this like as I told before, what we make, we import in assembly, like, and we cut. Here I have imported two cells. Why? Because we have to combine a, like keep in the series. Okay, so in series combination, so like see, if I remove, like if let's show you so that it will be better understanding. So suppose I have used this cell and I need a holder, like this is a holder. Now I have to mate this holder with this, so I will use the mate command, and with the help of, I will select with which the relation should be with surface. So suppose if I want the circumference of the circle, and also the circumference of this holder should be like interferentially fit, there should be a little gap. So we'll go for the concentric circle and we'll just select it, so it automatically make a mate and relate it. So this is how now we can move it, like we can, how at what distance we want to keep our cells at a particular holder, we can make it. After that, if you want to fix the holder, you need to give a certain constant, like you had to coincide. Suppose I have given a mate that this surface should be coincide with this surface, and now it will not move, and there will be a relation in which this surface is coincide with this surface. So this is how we can apply a relation between the cell and a holder. And after applying this relation, now I'm just removing this because I've already now after making this relation, you can do what you can use a command, as I told, linear command. And after this linear command for the positive I have made, and same for the negative I have made. Now, yeah, so this is the thing what we have explained you. Now the second is cooling system. So see here what I have choose as a liquid cooling system. So how there are various types of cooling system. You can make anything, like it's up to you. If you're a researcher, so you can make by your own. So like no, like we cannot directly fix that this cooling system is best, or the used cooling system is best. So design comes when you do something. So you when you make something new, or so I have what I in this as we I have. So this is how we have in this, like we have made a chamber. This is a chamber, like I'll show you one chamber. Okay, so this is a chamber from where actually you will see the liquid will be enter from this chamber, and it follows the it follows when it is connected, it follows the direction here. Inside this it will follow, and it will come out from here, take the heat from the chamber and come out from here, and this follows the loop. And this will be thoroughly, means the from with the help of pump the fluid will be flowing. Suppose we have input the fluid from here, so it will flow like this, like this, like this, and it will come out, and this will goes on. So this is one kind of design you can do it. Another, if you want, you can make another zigzag pattern. If you also you cannot, if you want an air cooling, then don't make these channels, just make a compartment and use some other techniques. And but your design is correct or not correct, you cannot say unless and until you do the analysis. So after, suppose I have made this battery pack and I have made a cooling system or a BMS, anything. Now I have to do the analysis of whether at a certain heat generation what I'm providing to the battery cell, this liquid refrigerant of my design is fulfilling it not. So what will how we can do it? We can save this file, save as, if we'll do save this file, if you want to do the analysis, we save the file in the IGS format or step format, because in ANSYS or any other software this file is acceptable. So you can save this file and import this file into the analysis software like ANSYS. And after that you can provide select the body, you can provide the liquid flow, and you can analyze whether your design is correct or not, or you want to do any kind of improvisation, or you have to change something. So this is how we are using a SolidWorks or any of the 3D software to do our to what we want to design. And with the help of the design we do the analysis, and we check whether it is correct or not, or we again will do the designing. So this is how the process basically goes on. I know many of you knows about the process, but this is like what I want to say, add on is like that. So this is how the battery pack exactly, what with the help of SolidWorks we make it. And we use the holder cells, and also okay, after that also, after this you we can make a housing for this, because housing is one of the most important thing. But now I have not made the housing. Why? Because I want to add something, that housing we cannot fix it. It depends on vehicle to vehicle, that what is the dimension of the vehicle, and according to that we make the housing. That if suppose we finalize that this battery pack is made and this cooling system we are using now, and even now what type of housing is, because we need to we have a space constraint, so according to the space we design the housing with the help of deep drawing method, like steels, aluminiums are used currently nowadays in the battery pack. Even in the battery pack, if I used to show you, like here, when we make a housing for this battery pack, so we are using a pressure equalization and condensation vents we are using it. Why? Because when we enclose our battery pack, so there will be a pressure difference, so we are using a pressure the device also, or like we are using a vent, so that there should be a pressure, there should not be a pressure difference. So this is also a part of the battery pack which we basically used here. And after like making all this battery pack and BMS and all the connections, we can also, if you want to see, we can go for the here in assembly only we have an exploded view option, so we can go, we can see the exploded, we can make our own exploded view, like if suppose we are making a project, or we just want to represent, like if you want to do a presentation, so we can make this with the help of this exploded view, we can like separate individual components. And after separating this, it will follow the track at what track you have made. And after this I'll show you, like this is how like I have made already. So this is what explode view will be there. Like this is how you can show, you can design, you can make, if you want to present it, that individual cells you have made this holders, strips, bed BMS, everything. Even you can animate as well. After, like you can make animations, and how this animation can be made, like from exploded view only, you can go here, this animation controller is there, so the path what you have followed, let where your like holder should be there, where you will cell will be there, strip, the it will track that path, and you will be easily able to visualize that what are the component is used, and how we can make this battery pack in the SolidWorks. So SolidWorks is very vast and it is very versatile. You can do anything here. You can change your design. You can make exploded. Even after doing this, after making this all things, you can. I have made just here one thing. Like you can make a like drawing. This drawing is basically I just made for only for like without any dimensions, just to show you that we can make all the views of this with the in SolidWorks only. There is an option if you go to the file and make a drawing from the assembly. So what the assembly we have, we can select from here, and after that we can make a drawing. Okay, you have to select what standard size of the sheet you want. So currently suppose I'm selecting A3, you can go for A2, it depends on what you want. And now from here you can select the views, like I have selected this, but by mistake it has been selected. So here you can directly go to the drawing and model view and select the model what you have saved. Now you can use, you can just see this is the model. Now automatically it will come the front view, top view, left side view, right side view. And now if you suppose it is coming very small, now if you want to enlarge it, so just click over the design what you want and just increase the scale. If you will increase the scale, it will like become little large. See, so if you increase the scale, the dimensions will come enlarged, like you will be able to see more. Now after that you can go for an isometric view, and suppose if you want to like use a bill of material what you have made, and you want to like make a bill of material, so you can easily make with the help of this software, you can easily make a bill of material as well. So here in under annotation and under table, we have lots of options like general table, whole table. So you just click over the bill of material, and it will automatically generate a bill of material over here. So one thing I just want to, while when you are generating a bill of material, so what the name, what you have saved, the part name, like suppose BMS you have saved, or suppose you have saved cell, for cell name is cell, it will you will be getting the same name in the bill of material. But if you want to change it, so it is not you have to change the file name, you can change, you can edit here also, automatically it will be done. So this is how basically I have made this, and it shows the part number, quantity. This is how. And also you can use this exploded view with the balloon structure, with the numbers that displays that which material is used, and what is the name of that material, and how, what is the quantity, and this. So this is how in SolidWorks we can make everything, like the design what we want. And so that only I just want to say, in SolidWorks or any on the 3D software, we need to know that what we want to make. Either it is a assembly or part design. If you want to make a part design, so what tools are required for to make that part design? So the person who knows SolidWorks, basically they know how to do. The person who don't know, so it will be little not harder, I will say. If they learn, definitely they can make it, and it is very easy software, and we can like make like what we want after making this assemble part and drawing part. And this is how we do the modeling in SolidWorks. So this is about the battery pack what we have made. We have made the exploded view, and we have made, after making this exploded view, we can like make the videos. This is all about the like battery pack design. So this is all about the software what I have done. And also what I was planned, I thought that first I use some like PPT presentation in which I could say that what are the components are used, because some components like CSC, cell supervision circuit, and cell interconnection, these are the new terms actually what I have like listened. So I thought that I should share with you all. That's why I have made some small PPTs so that I can explain that, and then go for the like SolidWorks. Because making a design within 1 hour, it is not possible, because it take times. That's why I have divided this part like this. So that's all from my side. Thanks.
Sir, can you share that PPT with us?
Definitely we can share.
Okay, sir.
If anyone having doubt, please ask from the expert. If anyone having doubt, please ask from the expert. You can unmute yourself and then ask your doubt.
Sir, any attendance form or a feedback form where we can get the certification that you have provided?
Hello. Sir, there is always a mismatch between the cell voltages. So when we assemble them, how we will take care of the mismatch between the cell voltages and cell properties?
So before assembling any cell, basically we are making the cells in the same voltage level using some cell balancing technique. After that we make a battery pack. Means in a cell testing machine we select the cell from which we are making a battery pack. So first we make all the cell at the equal voltage. After that we make a battery pack.
Okay.
Sir, but like pertaining to the previous question, I mean, even though you make the battery pack later, but there are a few cases that the a few of the batteries might fail after a certain while, right? Not every battery will be as efficient as the
Yeah.
other.
Yes,
So
yes,
how do
you're
you
right.
tackle that?
Basically that is the main function of BMS now. BMS basically coordinates which cell is not working, which cell is working, and it gives a feedback in terms of like with the help of CAN communication that this cell is not working, and or this cell have a less voltage or less state of health or state of charge. So before occurring any problem or issue, it gives a feedback so you can change it within a time. So that here BMS comes a role, makes good role about this.
Hello. Yeah, you have designed the SolidWorks model here, correct? Now, if we go for testing of the total model, do we have to assign the material here itself or in ANSYS?
No, sir. If we want to do an analysis, we had to assign a material with its property in a analysis software, right?
Okay, and yeah, now you have made this BMS part here, correct?
Yeah.
Then
Yes.
you have showed the cabling connections.
Yeah, definitely. Yeah.
Now, if we import this total model to ANSYS,
So
you
yeah.
know, so whether it will consider the BMS, because BMS is an electronics
No,
system.
yeah, definitely. So yeah, you're right, sir. In analysis, it depends what type of analysis you're doing. If you're going for cooling and thermal analysis, definitely you will not import this BMS.
Correct.
Okay, only you will import which is required, like the cooling system.
Cooling system
Okay,
and
the surface of
battery.
the battery or surface of the battery, because you're giving the internal heat generation only there. So
Yeah.
it depends on what application you're using, which
So
software.
electrical components we cannot basically import in ANSYS to do the testing and analysis.
According to my knowledge, because I'm not from electrical, so I don't know about that, and I haven't done it. So
Okay.
I'm sorry for that. I
Because
cannot give you the answer right now.
because this system is combination of electromechanical
Okay,
items. And
might be like I have worked on mechanical parts, so I have knowledge about that.
yeah, so for
Sorry, I
fitment,
cannot. Yeah.
for fitment, then durability testing,
Okay,
temperature testing, thermal testing, that can be done.
that can be done. Everything we can do it. Like yeah,
है ना? So
yeah,
these models can be tested for the mechanical aspects
yeah.
and thermal aspects or like that.
Structural aspects also.
Structural,
What?
correct. Structural analysis.
Yeah, yeah.
So if suppose we want to do both the testings, what you recommend? What type
Sorry.
of analysis for other things like electrical testing or simulation? Is there any other software?
Yeah, we can use MATLAB simulation. We can do the connection in that MATLAB simulation, and we can
Okay.
test the like how the voltage drop or how the wire connections is like measuring the voltage with the help of sensors. So we can use MATLAB simulating software for that.
Okay. And this suppose you have made the cell, है ना? You have made
Yes.
just only the this thing
Outer body, yeah.
outer body wire diagram, and then you have revolved
Definitely.
things, है ना?
Yeah. Yeah.
So whether the cell is similar to that or it contains other things, like it is simple a cylindrical body or it
So,
has
sir, while
electrode.
while analysis, suppose we have designed a battery pack. Definitely, after designing a battery pack, we'll do an analysis. Okay. So during analysis, according to my knowledge, what I have, we are giving a heat generation, what this battery pack exactly will at
Okay.
different C rate, how much heat generation will happen,
Heat
that
generation will
will
be there.
provide it. So internal chemistry is not matters at that time, right?
Internal this thing design is not matter.
According, yeah, what, yeah.
So what is the construction of cell internally? Because
So
there are different types of cells.
internally, actually, as we know that internally we have anode, cathode, even
Correct.
yeah, we have an
There,
electrolyte also.
yeah,
Okay,
there are layers of
layers. There are several layers, huh? Like
several layers in the
casing
cell,
is,
है ना?
yeah,
In
yeah.
the
We can
casing.
make it like in SolidWorks. We can make all these layers with the help of like commands. We can make it. But why I have not made this here? Because definitely now we are we are making a battery pack for some directly. We cannot make a prototype. We do an analysis part. Okay, so for keeping that in mind, I have made this simple. Even we can use all the components and the thickness and how much length out is there a die. We can make it easily with the help of SolidWorks. But it depends. Do you have the like 2D
Requirement.
requirement, and do like 2D sketch? You do have the 2D sketch as well of each, the length of
As
electrolyte and all things, right?
as you are into this field, what do you think? Matlab, the internal construction is needed or not
It
by
depends what,
industries?
like it is needed. Like, see, it depends on the application, as I told before. Na, it depends on at what application you're using. Okay, sometime it is needed. It is 100% needed. And suppose if you are doing a cell analysis only, like in we are using a cell testing machine. In cell testing machine, basically we are testing the cell internal chemistry and internal chemistry and voltage, like how much voltage. So sometime in some software it is needed, but according to the need we design it. So I think it is over. Thank you very much from my side.
Thanks, Jeff, for hosting the webinar. Your expertise and insight were invaluable for our learners. I would like to take the opportunity to introduce our company, ISI India product and services that we offer in EV technology with a small video. So kindly have a look on video.
As we are living in the fast changing world of electric vehicles, ISA India is leading a tech organization, paving the way for innovation and devotionalizing the ecosystem. It is bridging the gap between industry and academia and bringing all the stakeholders to the same table. From 2013, our parent organization has been tirelessly working to create an ecosystem for skill development, research, innovation, and entrepreneurship in the electric vehicle industry. Through CSR skill development and partnership with GIZ, Tata Technologies, Bharat Crop Science, Kalika Industries, Chalna Jan Seva, Masiya, IPCA Laboratories, etc. And with national and international e-mobility events such as Electric Solar Vehicle Championship, Formula Imperial, Indian Karting Race, E-Bike Design Challenge, we have provided a platform for over 3 lakh students from more than 750 colleges and universities to come up with the innovative projects. In addition to this, we are offering various skill development programs, faculty development programs, corporate trainings, and spectrum of courses with duration from 9 to 12 months with live and recorded interactive classes with the added flexibility of paying after course completion. For our contribution towards building sustainable way forward in EV, we have got recognitions such as the National Youth Award from Ministry of Youth Affairs, Government of India, Titans of Technology Award, EDN Star Award from Earth Network USA, and the Social Entrepreneurship Award. And we have also joined hands with Automotive Skill Development Council, All India Council for Technical Education, National Skill Development Corporation, Ministry of New and Renewable Energy, and various automotive industries, which validate our global impact and commitment towards excellence. We are now a global partner for talent nurturing in the automotive industry. We are fostering the youths for the global EV market and have recently joined forces with partners in Malaysia, Indonesia, and South Africa. According to the economic survey, in India, the market for electric vehicle is expected to grow really fast, about 49% every year from 2022 to 2030. This means we could see 10 million electric vehicles sold every year, in which led to 50 million direct and indirect jobs by 2030. We are committed to sustainable mobility solutions, and our industry-aligned programs cater to academia, industry, and government sectors. Our expertise in the industry has led us to design cutting-edge technological solutions for the growing electric vehicle industry. We promote project-based learning, hands-on training, skill development initiatives, vocational training, research, entrepreneurship, public-private partnerships, awareness and outreach programs. Our state-of-the-art facility, the Center of Excellence for Electric Vehicle, is dedicated to spreading the word about electric vehicles by facilitation of technological advanced solutions. EV Tech Lab. It's a high-tech lab designed for students studying engineering, ITI, and polytechnic students getting job training. Think of it as a space where creativity meets actual hardware solutions. People here get to dive deep into the physical part that make electric vehicle work. This model is also helping our partners for community skilling of various job roles, such as electric vehicle technician, vehicle assembly operator, charging station operator and technician, and workforce for electric vehicle powertrain, battery and BMS maintenance, etc. Second model, that is our Center of Excellence for Electric Vehicle. It's a combination of labs and offering both hardware and software solutions, under which we have established end-to-end solutions for electric and hybrid vehicle design, powertrain, battery and BMS, EV charging, IoT for experimental learning, testing and prototyping. The solution we are providing is unique and help our learners for upskilling, research by getting experimental data and plotting graphs. Our goal is to impart industrial knowledge by establishing pioneering center of excellence. These centers, developed in collaboration with universities, industry partners, and government entities. Our COEs provide integration of EV curriculum in BTech, MTech, and other academia programs. Research and vocational NSQ courses aligned with the National Education Policy. Plus, our COEs also support the startup ecosystem by providing facilities for design, prototyping, and product testing. Our labs are making difference. We have established several labs across strategic locations with all kind of stakeholders like industry, Hero Motocorp, with Government of Kerala in partnership with MG Motors at 2 locations, IIT Mandi, private universities like SRMU, Calcutta University, Sharda University, an NGO with Govardhaniko Village by ISKCON Temple, and various top universities and institutes across India. Our commitment to excellence is unwavering, and by 2025, we aim to establish over 250 plus Center of Excellence worldwide.